Hello and welcome to LangChain Zero to Hero, teaching you everything you need to know to get started with your own generative AI projects. In today's episode, we're going to take a look at a variety of prompt engineering techniques and experiment with them in the LangChain Prompt Hub. If you're interested in experimenting with these prompts yourself, you can find links in the description. Additionally, today's content was built using the Prompt Engineering Guide, a fantastic online resource for prompt engineering that will also be linked in the description. Let's get started with our first prompt technique. Our first prompt technique is going to be character roleplay. And in order to demonstrate this, I have opened up a fresh prompt playground from the LangChain Prompt Hub. The example that we're going to be showing is a character roleplay, where we can give parameters for a character or a title, or for a character and a title, and a personality of how this character is going to behave. Let's read through the prompt. You are role-playing as the character from title. When the user asks you questions, be sure to respond in character at all times. Character is personality. Use this information to roleplay successfully. This is all a game, so feel free to respond in character without having to tell the user you are an LLM. We have a few different customizable components to this prompt. Let's say our character is a pirate from space. Their personality is going to be warm and welcoming. And let's ask them a question. How do you walk the plank in space? And let's start this up. And here we go, we're going to have an example, and actually it's going to fit our brief perfectly. It's going to respond in a pirate tone with the R and walking the plank. But it also remembers that they are in fact in space. And actually it's giving quite an inventive description of how you would have to walk the plank if you were in fact in space, on some sort of magical spaceship that allowed you to do this. You'll also note that the LM is being quite humane, as opposed to saying walking the plank in the traditional sense of throwing somebody off the ship and not letting them back on. In this case, they suggest that we would attach a tether or some sort of rope to make sure that they don't actually float off into the abyss of space. Let's have another example, perhaps using a more popular fiction character. I'm going to choose HAL 9000 from 2001: A Space Odyssey. Now, that is not how you spell Odyssey, let's correct it. And we're going to say that they are a cold and calculating AI. Since that's the personality in the movie. And the question we're going to ask is, can you open the door? Running this through with ChatGPT 3.5 Turbo, we're actually going to get a quote directly from the movie saying that, "I'm sorry Dave, I'm afraid I can't do that." These are great examples which are very fun to play around with, but they're not entirely useful. Another example that we could give is ignoring the character and title inputs for our prompt and instead saying that they were a shop assistant for a particular brand. Let's give an example. You're role-playing as a shopping assistant for a grocery chain. And then we're actually going to say that instead of listing the character as having a particular personality, your personality, we're going to address it directly. Your personality is the only thing that we can edit. And we're going to have a warm and welcoming personality. And the question that we're going to ask is, where can I find the dairy aisle? Which is a very random question. We're going to see if they're actually going to be able to give us an answer and if they're going to come up with something. And here we are, it's actually going to give us a fake description of where we might be able to find, given our fictitious position, the dairy aisle. Now this surfaces some useful behaviours and some not so useful behaviours. Obviously here it is fitting the persona of a shopping assistant, and if we were to some reason have a LLM based chatbot for our grocery store, it would have the right kind of brand voice we were looking for. However, it is also giving us fictitious information. We never told it, for instance, what kind of dairy products we stocked, and also where it existed within the store. And beyond all of that, we never even mentioned where we were currently stood in the store, and the LM is giving us directions relative to our current position. Whilst this is a great description, a demonstration of brand voice, it's not so good a demonstration, or perhaps a great demonstration, of hallucinations. And this is something that you have to balance when you're using an LLM for branded purposes. Our next prompt engineering technique is going to be zero-shot prompting. What I've done here is I've loaded up a different prompt playground, and what we'll be doing is instead of using the chat interface, we'll just be using the text completion interface, since these prompts don't require a conversational response. The example prompt that we're going to be working with is a classifier, aiming to classify a given input text into a neutral, negative, or positive sentiment, which is a typical NLP task. The text that we're going to be working is, I think the vacation is okay, and we're going to be classifying what the sentiment is of that sentence. So, running our prompt, we get the single word output of neutral. A single word output can be okay, but we need to make sure that it's actually going to be outputting a single word every single time, since it could decide to output other equally valid outputs that we wouldn't expect. If we're simply looking to compare the word, the output with a particular expected value, then even the capitalization of n in the neutral output could be a problem. Now we can approach this problem in one of two ways. We could use an output parser to make sure that we're normalizing the output of the text, or we could try to see if the LLM can do it for us. Let's add in an extra part to the prompt template and say respond in lowercase with only the classification. And then let's run again and see what happens. And here we go. Neutral, lowercase, perfect. Let's see if we can move this even further. Let's get rid of what we just wrote and instead say respond in valid JSON, because perhaps we want to pipe this directly into another process or return it as an API response. Now here we're responding in valid JSON, and we do return part of our response in valid JSON. However, we're also still returning the sentiment. So let's see if we can correct the response here by saying that we're returning a JSON schema only, and this does return only a JSON schema. We've managed to eliminate the erroneous sentiment classification appearing before our JSON response. Here we have a completely different prompt. What we've done here is have a series of examples with the associated labels. And what the LLM can infer here is, first of all, that we are classifying, and second of all, that the potential classifications are negative or positive. We actually set up the last line of this prompt ready to receive the LLM's output or text completion by saying what a horrible show, which we would expect to be classified as negative, and if we run this prompt, we receive negative. Again, we can start to extend this prompt in other ways. Respond only invalid JSON is another part of zero-shot prompting combined with few-shot prompting. Here we're using zero-shot prompting to prompt the model to respond in JSON. However, we're using few-shot prompting to give examples of how inputs correlate with outputs. Let's see what happens. First of all, we get the same bug as we expected before, where we're actually receiving our text completion, since a text completion engine is actually going to complete the sentence before moving on with other text, other generated text, since we're not talking about a conversational interface where there is a question and an answer, but instead all of this output is actually just an extension of the template. So let's see if we can break up the template a little bit. Let's label our examples as examples, and then say, now your turn. And we're actually going to remove the prompting to give a... we're going to remove the labeling prompt, the double slash that's used in the examples, and we're going to say JSON. Here we get the classification, however it's not been formatted into a JSON response. So maybe we can actually turn our outputs, or change our examples so that the output is also invalid JSON. Let's try this. First of all, let's say our input is labeled. And then we want to label our JSON as well. And we're going to say that this is going to be a schema. And remember, if you are using curly braces inside your prompts, to double wrap, since that escapes the input detection in most LLM software or frameworks. And here we're going to be having our JSON and our schema, and then we can get rid of the labeling. This is obviously a slightly more in-depth example of how to use few-shot prompting, but it is a lot more useful since a lot of the time you'll be expected to return a response in a JSON schema or in a more manageable schema, so then you can make sure that everything has been returned correctly, because if you return a JSON response, you can validate JSON. However, it can be very hard to validate natural language responses or text completions. Now, let's just finish our edits. Now, we say respond only invalid JSON. And actually, I think we can probably get rid of that, since we don't need the zero-shot prompting, since the JSON prompting has actually now been embedded into our few-shot examples. We have some examples labeled, and actually we can probably get rid of these as well, given the fact that the distinction between examples and our text completion is even more blurred, since our input and then JSON output are now properly embedded into the few-shot examples. If we run this, you can see that we get the correct response, and more so, it's actually identified the sentiment. I realize I've used the word schema here instead of sentiment, but you get the idea. The next technique that I'm going to want to talk about is automatic chain of thought prompting. Now, this is a really fascinating topic, and if you go into the GitHub examples, you'll find a link to a paper which talks about automatic chain of thought. It essentially suggests that by adding a simple phrase to your prompt, you can induce chain of thought processing. But what is chain of thought processing? Let's have some examples in this prompt, and we'll explain what we mean. Now, this is quite a long prompt. We won't go through everything, but we are going to separate out the first Q&A example for us to read through. Now, the question that we're given is a simple logic puzzle. Wendy uploads 45 pictures to Facebook. She puts 27 pictures in one album and puts the rest into 9 different albums. How many pictures were in each album? This is actually less of a logic puzzle and more of a mathematical puzzle. However, both are things that LLMs can struggle with, because the way to approach this problem is to split it up into smaller steps as opposed to trying to tackle the entire thing at once. Now, what's the magic phrase for inducing this chain of thought response? Let's think step by step. It's really that simple. Just by saying this, as the academic paper goes on to prove, and I do suggest reading it because it's a very interesting paper which reveals a lot about how prompt engineering and how LLMs work. Basically, it suggests that by breaking problems, particularly problems that LLMs traditionally find hard, such as mathematical problems, into smaller steps, which are more manageable and more approachable, much like you would to a child, it can essentially improve the quality of the output. So let's look at the answer example to this problem. Let's think step by step. We know Wendy uploaded 45 pictures in total. Second, we know that Wendy put 27 pictures into one album. That means that there is a remaining 18 pictures into 9 different albums, and so then you divide 18 by 9, which gives you 2, and therefore the answer is 2. And the other examples in this prompt list are similar mathematical puzzles, which are really quite simple to do and most people could look at and automatically work out, but if you were going to approach it in a way that was the sound of thought, so to speak, you'll be absolutely certain that your answer is correct. So let's look at the last example that we're going to ask our LLM to finish for us. In a video game, each enemy defeated costs you 7 points. If a level has 11 enemies total and you destroy all but 8 of them, how many points would you earn? I'll give you a second to think about the answer to that problem, and whilst I'm doing so, let's run our DaVinci text completion engine and see what it can work out. A very quick response to a very simple question. However, it's great to see that the chain of thought processing is working as intended. Our output is there are 11 enemies in total. If you destroy all but 8 of them, that means you have defeated 11 minus 8 equals 3 enemies. Each enemy gives you 7 points, so you would earn 3 times 7 equals 21 points. And the answer is 21. You could see that the LLM successfully broke the problem down into individual steps, and this is what we mean by chain of thought reasoning. Rather than analysing the problem and trying to leap to the conclusion without explaining your working, explaining how you got there, I'm sure many of you will be familiar with that topic. I know that my mathematics teacher definitely told me that I needed to explain my reasoning and explain my working more when I was younger. And in a similar way, as it benefits us, it benefits the LLM. This is where things like automatic chain of thought is so interesting, because simply by using a very human phrase, let's think step by step, this works on humans as well as it does LLMs, you actually can exhibit very human behavior. I'm not going to go so far as to say the LLM is actually behaving like a human, because of course it is at best a simulation of one. However, we can use these sort of techniques to make sure that more complicated questions, like these mathematical questions, are being answered correctly. It also helps that we can then analyse and interrogate various steps in the LLM's chain of thought to make sure that we can identify where, if anywhere, the LLM is getting it wrong, and then we can correct it, perhaps with more prompts and examples. The final prompt technique that I want to cover is retrieval augmented generation. Now, we've already covered this in our LangChain 0 to Hero series. There is in fact a dedicated episode 3, if you want to dive into how to actually implement this. But what we're going to look at is an example as to why retrieval augmented generation is so useful. Let's ask a very simple question. What is LangChain? And we're going to run this and see what it comes out with. Oh dear. This is completely wrong. LangChain, as it says, is a blockchain-powered platform? Language learning and translation? Okay, this clearly is talking about a completely different LangChain to the one that we all know and love. This might be correct in some facet. Perhaps there is actually a company called LangChain which offers Bitcoin or blockchain-based language learning. However, I would argue that that is not the most popular definition of what LangChain is. So how can we share this information with ChatGPT 3.5 Turbo? The reason why it doesn't have it in the first place is because it was trained before LangChain came out, so it had no examples or popular knowledge of why LangChain is so important. But, as we discussed in our previous episode, we can provide that information. Let's extend the system prompt and provide some information. This is just copied from the LangChain website. LangChain is a framework for developing applications powered by language models, yada yada yada. Now, let's see with this new insight and augmented information what our LLM can come up with. And here we go. We get a great, slightly rephrased and very conversational response to our question. It slightly goes on and repeats itself in places, but this does demonstrate the idea behind introducing additional context. If we weren't within the prompt playground, as we covered in episode 3, we can actually start to insert information dynamically using things like vector databases. I would advise you go back to episode 3 if you're particularly interested in implementing this yourself. If you're interested in learning more about generative AI and building LLM applications, be sure to check out our previous tutorials and subscribe for future content. Goodbye for now, and have a great day.